In this section, we look at chemical reactions between acids and bases. Let's first remind ourselves about the pH scale, which is the colors we see when we test a substance with universal indicator. From the scale, we know that if a substance is an acid, it's found on the left-hand side of the scale, with red being a strong acid and yellow being a weak acid. The opposite to an acid is a base or an alkali, from dark green to purple on the pH scale. A soluble base is called an alkali. And if a substance is cancelled out, so the acid is cancelled out by the alkali, we get a salt, which is pH 7 or neutral. Let's focus on our first chemical family, the acids. Acids are hydrogen donors. Strong acids ionize completely. So in these ionic equations, we can see how hydrochloric acid ionizes into the hydrogen ion plus the chloride ion. Sulfuric acid ionizes into a hydrogen ion and a sulfate ion, and nitric acid ionizes into a hydrogen ion and a nitrate ion. We see that separate hydrogen ion each time, characteristic of a strong acid. If we have a weak acid, it's not going to ionize completely. If we have a look at this equation of ethanoic acid or vinegar ionizing, we see that there's hydrogens present in both products. That is because it does not ionize completely. Now that brings me very nicely onto the family of chemicals formed when an acid is neutralized by an alkali, the salts. But let's first look at how do we name the salt. Like you and me, the salt has a first name and a surname, if we want to use an analogy. The first name comes from the metal in the equation, in the reactants. And the second part of the name is derived from the acid that is used in the equation. Now remember, in the ionic equations, if hydrochloric acid is used, the surname is going to be chloride. If sulfuric acid is used, the surname will be sulfate. And if nitric acid is used, the surname is going to be nitrate. And that is how you work out the specific name of the salt in the equation. Now it's time to focus on the 3 neutralization reactions you need to learn off by heart. A general equation is an equation that you could use to substitute in specific chemicals to get the correct pattern. So here are the 3 general equations for neutralization reactions. If you have an acid reacting with a base, it forms the neutral salt plus water. An acid reacting with a metal forms salt plus hydrogen. And if we use a burning splint, the hydrogen will go squeaky pop, which is a unique property of hydrogen. And if an acid is reacting with a carbonate, it produces salt plus carbon dioxide plus water. Carbon dioxide can be tested by adding lime water, which goes cloudy. And that only happens in the presence of carbon dioxide. So we've got to get these in our head. So let's start wrapping. Acid and a base gives you salt and water. Acid and a metal gives you salt and hydrogen. Acid and a carbonate gives you salt, carbon dioxide, water. Your turn. Now, you might be laughing at me, but in the exam, when you do that and you can write the equations, you will be getting the marks. So if I take hydrochloric acid and a base, which always ends in oxide, like sodium hydroxide, I'm going to get sodium chloride plus water. Sodium chloride, the sodium comes from the salt in the reactants, and the chloride is because the acid used is hydrochloric acid. Acid and a base gives you salt plus water. And now, if reacting with the acid is a metal on its own, such as magnesium reacting with sulfuric acid, I get magnesium sulfate plus, this time, hydrogen. Magnesium is the metal and sulfate because the acid is sulfuric acid. And if I have nitric acid reacting with a carbonate such as calcium carbonate, I'm going to get calcium nitrate because it was nitric acid plus carbon dioxide plus water. So it doesn't matter which reactants are given to you, you can simply apply it. The final reaction in the series we're going to look at is what is known as precipitation reactions. This is when you react two solutions together and a solid or a precipitate forms during the reaction. And I show this by using the symbol S next to that compound. Let's look at this example. The colorless solutions of lead nitrate and sodium chloride are reacted together, and it produces a yellow solid called lead chloride and a colorless sodium nitrate. Now, how do we know that lead chloride is going to be a solid if we don't actually physically do the experiment? Well, unfortunately, we have to learn it off by heart. Silver and lead are the only chlorides that form insoluble substances. Lead, barium, and calcium sulfate are the only sulfates that will form solids. All the carbonates and hydroxides form insoluble substances except for sodium, potassium, and ammonium. Now, finally, take a moment to sit back and reflect. One of the best things we can do to get top marks is to test ourselves. Pause the video, see if you can answer these questions. Learn from your mistakes. Remember, the more you practice, the more time you give yourself, the better you get.